So now let's look at the
You're right.
Oh, I see.
So go get the shot and choose the Oh, you good job.
Easier than me walking the aisles. Let's make sure I have the right number.
They can read us out.
All right, so we're going to go in the notes packet. We are still in the notes. We're moving on. Quiz is only 20 minutes. So we're going to be on the section that starts 1.4. Which is in the notes packet. And I think nope, this one doesn't have page numbers on it. So. But it starts with 1.4 at the top. And we're going to be looking at rational functions, which are fraction stuff. So fraction expressions. Page 6. And again, I've given us our definitions at the top so that we don't have to sit here and writing them down all that much. When we have a fraction expression, all that means is it's a quotient, a fraction that has a polynomial in the numerator and in the denominator. We're going to be finding our domain and domain restrictions for these. We did this back in Algebra 2 when we did rational functions. But I know that was like March, so it's been a second. Really what we're looking for when we are trying to find a domain restriction on a fraction like this. There are going to be problems in the domain of a problem when we divide by what? What is the one thing in the universe we can't divide by? 0. So on fractional expressions, our domains are going to be all real numbers except for where our denominator equals 0. Because I can put any number in for x, but I'm going to get an error if the denominator equals 0. So there's going to be times we need to factor to be able to find this. There's going to be times when we need to do some simplifying as well. But a lot of what we're looking for is when is the denominator 0? So on this first one here, it doesn't matter really that our numerator is different than squares. What we're trying to do, trying to find our domain restriction with these, is I want to know when this piece, when our denominator equals 0. When x equals negative 3. Whoa, hang on, I gotta make my pen a same size again. When x equals negative 3, the denominator is 0. And that's a problem. Because we can't divide by 0. So what we're going to do is we're going to write a rule that is stated to restrict our domain. And really what it is we're going to say, well, when x equals negative 3 is the denominator, or when x equals negative 3, that's the problem. So our domain restriction is going to be that x cannot be negative 3. That's the domain restriction we're going to put. I'm just going to highlight that a different color. So this is our domain restriction. What we're starting with these is find where our denominator equals 0. It's the one thing we can't have as our answer, as our x equals, as a solution. We're going to come through and we're going to simplify these fractions, and we're going to state the domain restriction. So when we are simplifying fractions, just like when we were like if we do it with numbers or we do it with anything else like that, we can only simplify fractions when it's in factored form. Like coming through here, I can't simplify these individually. I can't simplify 2x and 4x, and I can't simplify 6 and 12. Since we have adding and subtracting inside here, we're going to need to factor first. We can only cancel things out when all the terms are being multiplied. So we have to put them into factored form in order to be able to simplify it. So on this one, let's take a look at how we could write this in a factored form. What can I do? Whoa, hang on, wrong pen. What happens when I do this paper size and it zooms in too far? What can I do with this numerator to factor it? Take out a 2. It's got a greatest common factor, a GCF. So if I take out a GCF of 2, what's left over? X plus 3. How about in our denominator here? We can take out a 4. What's left over? X minus 3. No, that's not important. Just making sure. Now, is there something we can simplify? With the 2 and the 4. Because 2 divided by 4 is the same thing as 1 divided by 2. We can simplify that out. So this is going to cancel out, and it's going to cancel out, leaving a 2 here. If you choose to mark your cancel out in some other way, that's totally fine. Just make it clear what's going on. I don't care how you mark it down. Just let me see what's happening. Because our final answer, and we're going to leave them in factored form, our simplified rational, our simplified function here, is going to have just our x plus 3 in the numerator. If you want to leave the parentheses, totally valid. If you want to drop them because it's the only term left, also totally valid. In the denominator, I am going to leave it in the parentheses. If you really feel like distributing it out, you can, but you don't need to. That is our simplified fraction. These two statements, or actually all three of these statements, are equivalent. They mean the same thing, and if I substitute in values for x, I should get the exact same answer. What is our domain restriction on this one? What's the one number that x can't be? 3. Because if x is 3, this statement will be 0, and 2 times 0 is going to be 0, and we're going to get an error. So x has to be anything except 3. So our domain restriction says that x cannot equal 3. And this is our whole answer. It's our simplified fraction and the domain restriction. Just leave like a little space between them. If you really want a symbol that you can put in there, you can put in a semicolon. I'm not going to be petty about that. As long as I can tell that there's a space, we're cool. Before I zoom over to that one, questions on that one? Cool. We're going to do the same thing over here on this one. We want to try and simplify it as much as possible, and we want to know what our domain restriction is going to be, if we can. So I'm going to need to get this into factored form so that we can see if we have any pieces that cancel out, and so that we can see where our denominator is going to be 0. So we're going to factor both of these pieces. So I'm going to take my fraction here, and we want to factor our numerator. So we need to figure out a pair of numbers that's going to multiply to make 6 and add to make -5. -3 and -2. I'm going to write it down over here just so that we can see. So I take my +6 and my -5, and we figured out that a -3 and a -2 multiply to be 6, and add to be negative 5. Just writing it down so we can see it in case we look at the PDF later. I can go straight into my factored form here because we have our a value of 1. So I don't have to do full factoring by grouping. I don't have to do anything crazy like that. We can take the shortcut method where we're going to have our x with our minus 3 and our x with our minus 2. Just going to make my fraction a smidge longer. Then I'm going to do the same thing with the denominator. We need a pair of numbers that's going to multiply to make negative 15 and add to make positive 2. 5 and negative 3. Does that show up? It's a little light. Again, if ever I pick a color that's hard to read or something with my handwriting goes funky, please let me know. I am looking at this at a very extreme angle and it's all pretty washed out for me. So, if you can't see something, let me know. It is so easy to change. Again, since our a value is 1, we can take our shortcut method. We've got our x with our positive 5, and we have our x with the minus 3. Do we have anything here we can simplify? X minus 3's. So we can simplify this fraction because these two pieces cancel out. We can only cancel them when it's in factored form. So that's why we have to factor both pieces. Our simplified fraction, we're going to have that x minus 2 that's left in our numerator. And we're going to have our x plus 5 that's left in that denominator. I don't have any other pieces, so I've dropped my parentheses. If you want to leave those in there, that's totally fine. It's not wrong. I just tend to drop the parentheses right there. So we have to get it in factored form to be able to simplify. What is our domain restriction going to be here? What can't x be? X cannot be negative 5. On our simplified fraction, that's the only piece that's there. However, we are doing our domain restriction for, the question we're asked. There is another problem child in this denominator. It's the one that canceled out. If we were graphing this, this would be where we have our removable discontinuity, like the whole, looks like somebody stabbed the graph. It still counts as a problem for our domain. So what other number can't x be? 3. So x can't be negative 5 and x can't be 3. So you could either write them as two separate statements. You can put them as like or 3, or you can just say like x cannot be negative 5 or 3 and put it as commas. That also works. Yes, dear.
So you were saying like with the holes in the graph, like how would it go? Like would it go from like 0 all the way, or like from like it would stop at negative 5, like the hole would be at negative 5 and the hole would be at 3, right?
So if we were graphing these, the rational functions, because it's been, I know it's minutes since we've seen them, these are the ones that kind of look like these. I might get a different color. These pieces. And what we would have is we would have an asymptote at the negative 5, where our problem is in the denominator. And where that hole is would be one of those guys. So the ones that are left in the denominator, and when we will graph these later in the year, and don't think it's first measure. But we'll go through how to get to all these pieces when it comes time. Right now, we're just going to simplify them. We've seen it before, but it's been a hot minute. Do not stress about this.
Okay, thank you.
Yeah. Just so that we have the visual, because we have seen it before, but we ain't going to stress about that right now. And just highlighting our answer so we have it. This is our answer. And you don't have to have both of the restrictions, just one. So you can list them separately. You can put two sets, x can equal negative 5, x can equal 3, or you can just put them next to each other with a comma. I don't care. I won't be petty about that. Not something that's worth All right, let's do another one. Let's come down here. Because that one looks weird. It looks weird. Everything feels backwards. What could we do on this one? And don't say cry. Say, don't say cry. What's our instinct on this? Let's try by grouping. I see 4 terms, so let's see if we can do this by grouping. I'm going to rewrite it down here just so I can do this as a whole line over here. So I'm going to have my 2x plus 4 minus x cubed minus 2x squared. And if I break these into pairs, like this, what can I factor out of this pair? 2. So I can have 2, and that's going to leave me with x plus 2. What is the common factor of these 2 terms? Negative x squared. Whoa, but it's a thing. Gross. Minus x squared. Ew. What's left over when I take out a minus x squared? X plus 2. As long as these 2 things match exactly, we can finish this factoring. They have to match all the way down to the signs. So I can write our numerator here as x plus 2, and then our 2 leftover pieces make their own factor, 2 minus x squared, which is gross, but it is factored. Ew. But this is how we can rewrite our numerator here. So I'm going to use that. I'm just not going to rewrite it again. If you want to recopy it and put it in a fraction, great. I'm just going to draw a line under it and put the denominator underneath because I'm going to be lazy. So our numerator factors down to this. What does our denominator factor down to be? What do we know that multiplies to be 6 and adds to be 5? X plus 3 and x plus 2. Do we have anything that can simplify? The x plus 2's will leave. So we can rewrite our simplified fraction 2 minus x squared. If you want to put it minus x squared plus 2 because you don't like having the x squared at the end, that works. X plus 3 is the only thing left in our denominator. We're going to end on this one. So let's find our domain restriction, and then we'll be done. What cannot be the value of x? X cannot be negative 3. Or negative 2. Because our factored form has that here. So x cannot be negative 2. Okay? We'll work with this a little bit more, and then we'll get into some operations with these rational functions tomorrow. Schmerp.